Have you ever tasted a lemon or lemon juice or curd or tomatoes? How do they taste? Yes, they all have sour taste. Now lemons, they have citric acid in them. Curd has lactic acid and tomatoes, they have oxalic acid in them. So, it is because of the presence of these acids they have sour taste. Now, baking soda or Eno, toothpaste or our regular soaps, they all have bitter taste. It is because they are bases, so bases have bitter taste. So, in this chapter, we are going to learn what are acids, what are bases, and how they neutralize to form salts. So, without wasting any further time, let's begin. First topic of discussion is acids. Acids are those which produce H plus ions, that is hydrogen ions in water. Now as you can see here, HCl, it dissociates in water to form H plus ions and Cl minus ions. So they produce H plus ions, therefore these are acids. Now hydrochloric acid or HCl and sulfuric acid or H2SO4 are two examples of acid. So as we have seen earlier that acids, they have sour taste. Chemical substances such as phenolphthalein, methyl orange, litmus, they tell us whether the given substance is an acid or a base by changing its color. So, as they indicate the presence of acid or base, they are known as indicators. So, phenolphthalein is a colorless substance. When it is added to an acid, it does not change its color. But when added to a base or an alkali, the change in color is observed. It changes its color from colorless to pink. So, if it does not change its color, it means the substance is acidic. But if it turns pink, it means the substance is basic. Now, methyl orange. Methyl orange is orange in color as you can see here. So when it is added to an acid, its color does not change. But when it is added to an alkali, the change in color is seen. It changes its color from orange to yellow as you can see here. Acid, it turns blue litmus red as you can see here. The lemon which has citric acid in it changes the blue litmus red. Red litmus, when dipped into an alkali, it turns into blue. So, bases, they change the color of red litmus to blue. As you can see here, the red litmus turns blue when dipped in an alkali. Now, this is the pH scale. 1 to 6 denotes acidic pH. 7 denotes neutral pH and 8 to 14 denotes alkaline pH. Now, what is pH scale? What is its importance? We will see later in this video. So, stay tuned. So, the properties of acids. These are the properties of acids. They turn blue litmus red. They have a sour taste. They corrode metals. They are good conductors of electricity. They neutralize bases to form salt and water. And as we have seen, they measure 0 to 6 on pH scale. So, let's have a look at chemical properties of acids. Now, reactions of acid with metals. As you can see here, the magnesium stripped reacts with the dilute acid forming gas bubbles. So, metals here, which is magnesium, reacts with acids to form gas, mainly hydrogen gas. Magnesium, which is the metal here, reacts with HCl, which is the dilute acid, to form MgCl2, salt and hydrogen gas. So metals reacts with acid to form salt and hydrogen gas. Now reactions of acid with carbonates and bicarbonates. Metal carbonates or bicarbonates react with acids to form salt, carbon dioxide and water. So even here the formation of gas, which is carbon dioxide, takes place. Now, as you can see here, copper carbonate is added to acid, which is HCl, and this leads to the formation of gas bubbles. Now, these gas bubbles are nothing but carbon dioxide. So, copper carbonate reacts with HCl to form salt, water, and carbon dioxide, which is seen in the form of bubbles. This is the another example. In this bottle, sodium bicarbonate, that is baking soda, is added into acetic acid, which is vinegar. So, even here, when bicarbonate is added to an acid, it leads to the formation of CO2, which fills the balloon. So, this is the experiment done using baking soda and vinegar to show that bicarbonate, when reacts with acid, it forms gas, which is nothing but carbon dioxide gas, which fills the balloon. Now, reaction of acids with base. You can see here that HCl, it reacts with NaOH, forming NaCl and H2O. So, acid neutralizes the base, forming salt and water. Now here phenolphthalein is added to sodium hydroxide. So as we know, sodium hydroxide is a base. So it turns from colorless to pink. And when acid, that is HCl, is added to NaOH, it neutralizes the effect of base, and thus the color changes back from pink to colorless. This process is called neutralization. Here, acid and the base, they both neutralize each other, forming salt and water. Now, reactions of acid with metallic oxides. Now, copper oxide, it reacts with HCl, forming copper chloride, which is the salt, and water. So here, when copper oxide, after reacting with HCl, it changes its color to bluish green. This indicates the formation of copper chloride, as copper chloride is green in color. So, copper oxide plus HCl forms CuCl2 plus H2O. We'll start with bases now. Bases are those which produce hydroxide ions, that is OH minus ions, in aqueous solution. Bases which are water soluble, they are known as alkalis. Now here you can see that NaOH dissociates into Na plus and OH minus ions, so they produce OH minus ions in water. Sodium hydroxide, that is NaOH, and ammonia are the examples of bases. Now as we have seen, bases have bitter taste. So here you can see bases taste bitter. Like acids, phenolphthalein, methyl orange, and litmus are used as indicators. Phenolphthalein in base changes its color from colorless to pink. Methyl orange changes from orange to yellow in alkali. And red litmus changes to blue in bases. These are the properties of bases. They turn red litmus blue, they have bitter taste, they are slippery to touch, they also conduct electricity like acids. They react with acids to form salt and water, and they measure 8 to 14 on pH scale. Now let us discuss some chemical properties of bases. Now, reaction of bases with metals. Metals reacts with bases to form salt and hydrogen gas. So even here hydrogen gas is formed. So NaOH, which is the base, it reacts with zinc, the metal, to form salt, Na2ZnO2, and hydrogen gas. Reaction of bases with acids. So we have seen neutralization reactions. So bases reacts with acid to form salt and water. So KOH reacts with HCl to form KCl and H2O. Reaction of bases with non-metallic oxides. Base, which is NaOH, reacts with carbon dioxide to form salt, which is Na2CO3 and H2O. These are the properties of acids and bases and similarities between them. So the similarities are they both react to litmus, they both are compounds, they both release ions into solution, they both form salt and water when combined, and they both are good conductors of electricity. pH scale. Now, strength of an acid or a base can be found out using this pH scale. It measures the concentration of hydrogen ions in a solution. We have seen one pH scale before. So, this one, as you can see, to the left of 7 are all the acids or the compounds which are acidic, and to the right side are all the basic compounds. The 7 denotes the neutral compounds like water. So, if the pH is equal to 7, it means the solution is neutral. If the pH is greater than 7, it means the solution is alkaline. And if the pH is less than 7, it means the solution is acidic. Importance of pH. The human body. Now, human body works at a pH of about 7, which is a neutral pH. Stomach has a pH of 2, which is acidic due to HCl present in it. The tooth, it starts to decay when the pH of acid is formed in the mouth, which is below 5.5. Now, plants. Most of the plants grow best when the pH of the soil is close to 7, that is neutral pH. So, if the soil is too much acidic or basic, the plant's growth will be affected. It will grow badly or it will do not grow at all. Salts. Now, the salts, when acid and base they neutralize, salts are formed. Strong acid and strong base combines to form neutral salt. So HCl is a strong acid, NaOH is a strong base. When they both neutralize each other, a neutral salt, that is NaCl, is formed. So strong acid, strong base forms neutral salt. This is the same thing. Similarly, now weak acid and strong base, they form basic salt. This is the example. Acetic acid is a weak acid. NaOH is a strong base. So they form basic salt, which is sodium acetate. This is the picture of sodium acetate. Now strong acid and weak base, they combine to form acidic salt. HCl is a strong acid. NH4OH is a weak base. So they form acidic salt, which is NH4Cl. So NH4OH and HCl, they form NH4Cl.